tautology is nothing but the truth value which you get finally right, that should be always 1. Okay, that's known as a tautology. And contradiction means for all the combinations of the p, q and r values, the final value should be 0. Okay, so that's a contradiction. So the first question is, we have to prove that the following proposition is a tautology. Okay, so we'll divide into smaller parts. First we'll write p, q and r. Okay, and we'll write the binary values here. Okay, then we are taking each statement here like p or q first. Okay, and then we'll find the truth value for p or q. Okay, so 0 and 0's p or q is 0. So in that way you will fill for all these values in this column. Okay, after doing that you have to take the next step. The next step is p or q conditional r. Okay, so you have to write this separately here, and you have to find p or q conditional r. See, for the conditional, remember one thing, the truth value of the conditional will be 0 only when p is 1 and q is 0. Okay, in that case only the truth value of this conditional is 0, rest all the time it is 1. Okay, now keeping that in mind, you have to fill this value. Okay, I'll show you for one example. See here, p or q conditional r. Okay, so 0 conditional 0. What is 0 conditional 0? According to the truth table, it's 1. Okay, so in this place you will write 1. Okay, similarly you will do for all these values. Okay, after completing that, see what's the next term here, not r and not p or q. So not p or q, you can take it directly from here, write the reverse value. See here it's 0, write here 1, 0, 1, and in the place of 1 write 0. Okay, after filling this, and not r, if you want you can write, or you can just take directly. Okay, then the next one is not r conditional not p and q, means take this not r and not p and q and find the conditional. Okay, then in this column write those values. After that you have to do the final step. You got this term here. Okay, and this term is present here. Now what we have been asked is biconditional. See, the truth table for biconditional is this. In biconditional, if both values are same, then it is true. If it is different, then it is false. Okay, now using that you have to compare these two columns, this one and this one. Wherever it is same, you have to write 1. Okay, as you can see, both the values here are same in these columns, so all the truth values will be 1. Okay, so that's a tautology. Okay, in the next question also similarly you have to do, take the single terms p, q and r and fill it, then p or q, then write q conditional r, then find the and. Okay, after writing that, p conditional r. After doing all of this, you have to finally find the conditional of this whole term. Okay, then this also you will get the tautology. Okay, so similarly the other question is also in the same way. Okay, this for the tautology. In this question we have been asked to prove the following without using truth table, means by using laws of logic we have to prove. Okay, now the terms will be given in this way. We have to prove that this is logically equivalent to this one. First consider this part. In this part we have p conditional q conditional r. Okay, p conditional q conditional r. Now expanding this, take this as a single term like x and take this as a y term as y. Now x conditional y will be the term. Okay, x conditional y. X conditional y can be written as not x or y. Okay, according to this law. And applying this one, not x, what is x? We have considered p, right? So not p will be here, and y what we had considered, q conditional r. So we'll write q conditional r here with a or. Okay, that's the first step. In the second step we'll apply the same thing here also. For this conditional we'll get this, and we'll take here not as common, and by De Morgan's law we can write it in this way. And this or r is here, and if you apply the reverse conditional here, means see this can be converted to this as well. So this this term here is in this form, and if you convert it back to the original form, you will get it in this conditional form. Okay, in this question we have been asked to prove the following as logically equivalent. So in LHS we have two parts, which is having an OR gate in between. Starting from LHS we have this part. In this part we will take not p and not q as common. Okay, and here from this part we will take r as common. Okay, after taking r as common from here and here, then we will get in this way. Applying De Morgan's law we will get this one, and this is same as this one here, and by taking r as common and in between an or gate, we will get this equation. And by using identity law, what we can write it as, we can write it as true value. So r and true value is nothing but r according to identity law. Okay. In this question we will start from LHS. Here we have p conditional q, and this will write in the other way, like not q or r. Then by using absorption law, we will write not q here. Okay, not q and not q or r, that can be written as not q. So we will write that here, and by using the conditional law of conditional, we can write p conditional q as not p or q. By using the distribution law, we will take this not q inside. Okay, so we will get two terms here, and this one will get cancelled because not q and q is false statement, and since we have or here, we can neglect this false statement and we will be remaining with this. Now applying De Morgan's law here, okay, applying De Morgan's law, we will get in this form. Okay, that is the final answer. In this question we have to test the validity of the following statements. Okay, so we have been given three statements. We will break this into three sentences. First one is I study will be taken as p, I fail in examination will be taken as q, and I watch TV in the evenings will be taken as r. So accordingly the given argument will read as p conditional not q. Okay, see for example p conditional not q. What is p? P is I study. If I study, I will not fail in examination. I will not fail in examination is nothing but not q. Okay, because q is I will fail in examination and not q is I will not fail in examination. So we will write the first statement as p conditional not q. Similarly, we will write the remaining statements also in the same way, and then we will try to simplify it using laws of inference. Now the first statement here is p conditional not q and not r conditional p. Okay, first we consider both of these and we apply contrapositive here. Okay, conditional is equivalent to contrapositive, so we will apply contrapositive here and here. Okay, q will be remaining same here. After applying contrapositive and law of double negation, we will be remaining with this equation, and by using the rule of syllogism, we will obtain this equation. Okay, then further by using modus ponens rules, we will get this r here in the final equation. In the next question, we have been asked to test the validity of this statement. So we have been given four sentences. First one is A gets a supervisor position, A works hard, he will get a rise, he will buy a new car. Now according to these sentences, we will frame this statement by using the letters here P, Q, R and S. Okay, so after doing that, we will be obtaining this and we will be simplifying this using laws of logic. Okay, by using modus tollens, we will get we will simplify this equation and write here this one is the same, and in the next step we will use the laws of inference to simplify and get this final equation. Okay, so thus the given argument is valid. In this question we have been given the values of p, q and r, which is 0, 0 and 1. So by applying these values in these equations, we have to find out the final answer. Okay, so let us see the first one. The first question which we have been asked is p and q conditional r. Okay, so in p and q conditional r, p and q's value is 0 and r's value is 1. So 0 and 0 is 0, and here we have 1. So according to the truth table of the conditional, we will get this final result as true. In the similar way, we will do for the second one, which is p conditional q and r. So first we will find out what is q and r, then by using the truth table of conditional, we will find the truth value. Okay, similarly for this question and the last question as well. Okay, in this question we have been asked to find the possible values of p, q and r for the following to be false and for this to be true. For this one to be false, this p should be 1 and q or r should be false. Okay, so p is 1 and q or r is 0. So according to truth table of OR, this will be only 0 when q and r both are 0. Okay, if either is 1, then the truth value will be 1. So in this case, q and r should be 0. So the final values of p, q and r are 1, 0 and 0. Okay, similarly in the second question we have been asked p and q conditional r to be true. Okay, so if this is to be true and this is an AND gate used here, so p should be 1 and q conditional r should be true. Okay, so p is 1 we got and q conditional r should be 1. Okay, now q conditional r will be false only when q is equal to 1 and r is equal to 0. Okay, so except these two combination, all other combinations are the possible truth values. Okay. In this question we have been given that the p conditional q is false, that means p is 1 and q is 0. Okay. So by knowing the p and q values we have to determine the truth values of these all the statements. Okay. So for example the first one, p and q. So since p conditional q is false, that means p is 1 and q is 0. P and q, what is p and q? 1 and 0, that is 0. Similarly not p or q, what is not p? Not p is 0 and q is also 0. So the OR value of 0 and 0 is 0. Similarly for the third, fourth and fifth one. Okay. Been asked to establish the validity of the following. Okay, they have given a statement here and we have to establish the validity. So for this first we will take this, these are general terms. Okay, see if they give p of x and q of x, it's general terms. We need to convert it into specific terms and then find the validate this argument. So first we will write these things as like p of x and q of x as p of a or q of a. Similarly for all we will do, and then we will apply the rules. Okay, so first considering the first two statements we will write as q of a due to disjunctive syllogism. Then the second and the means q of a and this one, these two statements can be considered and written as r of a due to disjunctive syllogism. Then after that we will combine these terms and this term as a single entity, and by modus tollens we can write the following. We will get not s of a and we can write for some x not s of x. Okay, means from specification we are converting back to general terms. Okay, because in the question we have been asked to convert in the form of general term, so at last we will write in that form. In this question we have been given this term and we have to find the s or t. In the final answer we need to get this. Okay, for that first we will consider this term, and by modus ponens rules we can write this as q, and this will be the same thing we are writing here. Then we will be considering q and this one, these two terms will be will consider and write it as not r by modus tollens rule. And considering these two terms by conjunctive simplification, if two terms are there and is there, both of these are true, right? So any of these we can take here. So in the question they have asked to consider this, so we'll be considering this one here. Okay, in this question we have been asked to prove that u is also true, and by using these statements. So firstly we'll write these statements in the form of AND gates, and we'll be considering these two first. Okay, by using the loss of reference by using loss of inference we'll write this, and by simplifying these both we'll write here, and in the same way we will do all of this for simplification, and at last we will get these two terms. Okay, by and in between both of these and is there. Now what we have to prove, we have to prove that u is true, means u's value is 1. That's our task, right? So what we'll be doing is consider here these both terms final value is 1. Okay, so both of these should be 1. Since AND gate is used, both of these values should be 1. X and y both are 1. Now considering x, what we have is r and t and s. So r and t and s both values should be 1. So r and t is 1, s is 1. We got this, right? Then after this we will apply this r and t value in the next equation, which is in y. So this whole value is 1, and not r of t means not 1, which is 0, or u is here. Okay, so 0 or u, that's final value is 1. So when this both are there, see here 0 or u, the final value is 1, so u must be 1 to get the final value as 1, right? So we'll get the final answer as u as 1. So that's what we had to prove in this question. Okay, in this question also we have to do the same thing as in the previous one. Here we have to prove that s is 1. Okay, so firstly we have been given p is 1, so by this we can write 1 conditional r. This is 1. Okay, 1 conditional r is 1, so r's value must be 1. If it's 0, then the final value will become 0. That's not possible, so r is 1. So we got p and r value as 1. So in the same way we will apply those values and find out till at last we will get not s is equal to 1. Okay, if not s is equal to 1, then we can write the given argument is valid. In this question we are using disjunctive syllogism to simplify the following equation. First we will consider the second and third equation to get not p. Then by using not p and p or q, by using both of these we can write it as q according to disjunctive syllogism. Consider these two terms first. We can write these two terms as not p or q conditional s or t. Okay, so we will be writing that here. And in the next line we have been given not s and not u is 1, means these both values overall value is 1. So not s and not u, both value is 1, right? Both value is 1, then only we'll get the final value as 1. So if not s and not u both are 1, that means s is equal to u is equal to 0. Okay, so we got s and u value. By applying the u value here, we'll get the t value as 0. Now since we got the t value, we'll be using the first statement which they had given and applying the t value, s value. Okay, after applying the s value and t value, we'll get 0 here. Okay, now for this statement to be true, see the conditional is of this form p conditional q. Now q's value is 0, so p conditional 0. If this is to be true, p should be 0 only. If p is 1, this one will become false. Okay, but it's not false, it's true here, so p's value should be 0. Now instead of p we have here not p or q. So what we'll be doing is not p or q is equal to 0. Okay, because this must be 0 for this whole statement to be true. Now not p or q is 0, that means not p and q both are 0. That then only we'll get this final term as 0. So not p and q both are 0, that means not p is 0. So we can conclude that not p is 0, and therefore if not p is 0, p is 1, and hence the given statement is valid. Okay, we had to prove that only here. We had to prove that p is true. In this question, start from here. Not t and q means q is 1 and not t is 1. If not t is 1 means t's value is 0. We got the t's value and q's value also we got, which is 1. Okay, now by using these both values, we will be solving the upper equations. Okay, consider the third equation here, q conditional u and s. Okay, so q conditional u and s is 1, that means q's value is 1, conditional u and s is 1, so this must be 1. Okay, so for the final answer to be 1, u and s must be 1. So if u and s must be 1, that means u and s both individual value should be 1. Now we got the u and s value, we'll be applying that in this equation, the first equation which they had given, and finding the p's value. Okay, we'll be starting from here. Here we'll get not t as 1, that means t's value we got as 0. Now if t is 0, that means r conditional t, its final value is 1. If t is 0, r must be 0. Okay, so we got r value as 0. Now we'll be applying the r value in the first equation. Okay, when we apply r's value in the first equation, we'll get here as r and s as 0 here, so not p or not q, that not p or not q conditional 0, that's its truth value is 1. So this value and this value both should be, this value should be 0. Okay, because 0 conditional 0 will give 1. Okay, so not p or not q, this value is 0, so both of these should be 0. Not p is 0, p is 1. Okay, hence the given statement is valid. See, one thing you need to remember is the statements which they give here, both truth value is 1. By using these truth values, you have to prove the following statement. Okay, so first for this question we'll start from here. We'll consider not r of x as true. If not r of x is considered as true, that means r of x is false. Okay, so if r of x is false and you consider this statement here, and we can write as not p of x and q of x conditional 0. Okay, because of r of x. Now this whole value is 1, that means for this value to be true, this one should be 0, right? So if that is 0, we can write the statement as not p and q of x, these both are 0. Okay, that means either this one or both should be 0. Okay, but we have been given that p of x or q of x is 1, means either of this is 1. Okay, so now what we can do is, we'll be using the law of conditional here, p conditional q, that can be written as not p or q. Okay, then we'll be expanding it using De Morgan's law, and we'll be writing this in this form. Now this was for the simplification of the second one. Okay, second statement. For the first statement which we have here, which is p of x or q of x, okay, that will be writing in combination with this one. Okay, second statement. Now the second statement and the first statement are written here, and we'll take p of x or q of x as common. When we take that as common, and we'll be remaining with q of x and not q of x. Q of x and not q of x is false statement, so p of x or f naught means 0. Okay, now p or 0, but its final value is 1 here, and p or 0 is given, that means p must be 1, right? So we'll get as p of x is true. Okay, therefore not r of x conditional p of x is true for all x. Okay, In this question we have been given 4 statements and we have to prove the following questions which they have given. Okay, in the first question we have been asked for some x, p of x and q of x. That means for any of the value of x, any one value of x, you have to prove that this statement is true. Okay, so for the first one we can take x value as 1. Okay, see what's p of x. If we take x as 1, p of x is true, and if we take x as 1, q of x is also true. Okay, so therefore p of 1 and q of 1 both will be true in this first case. Okay, so that same thing we will be writing here by taking 1 as an example. Okay, its truth value is 1. Then after that the second question also is similar. You have to prove that for all x, p of x conditional q of x. Okay, so for this question we'll be taking the we have to prove for all real numbers. Okay, now since this is a conditional p of x conditional q of x, now this can be false only when q of x is 0, because in conditional the truth value will be false only when this q will be 0. Okay, if q is 1, no matter what p is, the final value will be 1. Okay, so whenever q is 0, at that time the conditional truth value will be false. So in this case the q's value is x square is greater than or equal to 0. For any value of x you can't get x square less than 0, because we can't get any x square which is less than 0, which means negative. Okay, since the set which we are considering is real numbers. Okay, in real numbers we can't get x square less than 0. Okay, so in this case q of x will be true in for all the values of x, so its truth value is 1, this conditional truth value. In the third question we have been given q of x conditional s of x is true or not. So for this to be false, what we have to do, we have to prove that s of x is false. Okay, see s of x is given as x cube x square minus 3 which is greater than 0. Okay, it's false for x is equal to 1. See, put the value of x as 1 here, you will get as minus 2, but minus 2 is not greater than 0, so this value is false, right? So s of x is false, therefore its truth value is 0. In the next question we have been given r of x or s of x is false. Okay, that means we have to prove that r of x and s of x both are false for at least one value. Okay, if you take x is equal to 1, okay, what is r of x? R of x is x cube x square minus 3x minus 4. If you take it as 1 here, 1 minus 3 minus 4 which is not equal to 0, so r of x will be false. And if you take 1 here, you will get as minus 2 greater than 0, this is also false. So if you take the value as 1, we will get both the statements as false, right? So its truth value is 0. Okay, in the next question we have to prove for at least one value this statement is true. Okay, for some x they have asked, so for one value of p of x and r of x, the both should be true. Okay, so for this one we can take x value as 4. Okay, so if you take x as 4, consider here p of x, 4 is greater than 0, right? So p of x is true, and in r of x, put the x value as 4 here, you will get as 0. Okay, so r of x is also true. So in this question, if you take the value as x, the value of x as 4, we will get this statement as true, so its truth value is 1. In the last question we have been asked r of x conditional p of x. So to prove that it is false, you have to prove that p of x is false. Okay, so consider x is equal to minus 1. Okay, since minus 1 is less than 0, p of x will be false, and if you take r of x and put the value of x as minus 1, you will get this as true, so r of x is true, 1 conditional 0. Okay, so this will be false, so the last one is false, its truth value is 0. In this question we have to find the converse, inverse and contrapositive of the conditional. Okay, so this is the conditional which is given, divided into two parts, p and q. Okay, so this is p and this is q. So in converse what we will write, if the given conditional is p conditional q, the converse will be q conditional p. Okay, so first we will write this and conditional this. Okay, so x square greater than 9 conditional x greater than 3. Okay, so similarly inverse is not p conditional not q, and contrapositive is not q conditional not p. So we'll find not q and not p and write the following. Okay, so these three things we have to write in the final answer. In this question we are asked to give a direct proof of the statement if k and L both are even, then k plus L is even and KL is also even. So since k and L are given to be even, we can write k as 2m1 and L as 2m2. Okay, so k plus L, if you add 2m1 plus 2m2, you can take 2 as common, so we will be remaining with 2m dash. Okay, so k plus L is even. Similarly KL is 4 m3. Okay, we'll get as 4 m3, so KL is also even. Hence if k and L both are even, then k plus L and KL are also even. In this question we have been given that to give a direct proof for the statement if n is an odd integer, then n plus 9 is an even integer. Okay, so since n is odd integer, that can be represented as 2k plus 1. Okay, if you add 9 in both sides, you will get 2k plus 10 and take 2 as common, so we'll get 2 into k plus 5. Okay, so 2 into k plus 5 can be written as 2k dash. Okay, so n plus 9 is even. In this question we have to write the following statement in symbolic form and find its negation. So mainly two things are given. First is x is an integer and x is a rational number. We'll take it as p of x and q of x. Then z is a set of all integers and q is a set of all rational numbers. Then the following statement, which is all integers are rational numbers, that can be written as for all x belongs to z, q of x. Why q of x is x is a rational number. So all integers are rational numbers. Integers are represented by z. Okay, so for all x belongs to z, q of x. Okay, all integers are rational numbers. Then and is given, so we'll use and here, and sum is given, so that symbol we'll use rational numbers. Some rational numbers are not integers. Okay, not integers means not p of x, and some rational numbers are not integers, so rational numbers have been given, so we'll use q. Okay, now we have been asked to find the negation of it. Okay, so this is of the form p and q. Okay, so negation p and q can be written as negation p or negation q. Therefore you have to apply the negation on this and this. Okay, so see here, if you apply the negation on this sign here, this is all x. Okay, for all x, so the negation of all x is sum x, so we'll write sum x here, and the q of x will become not q of x. Similarly here also we use we had used sum x here, so that sum x will after applying the negation, sum x will be all x. Okay, and not p of x was here, so that will become p of x. Okay, you have been asked to give 3 types of proof: direct, indirect, and proof by contradiction for this statement. Okay, so let's see how to do that. Firstly we'll consider square of an odd integer is an odd integer. So let n be an odd integer, so it can be written as n is equal to 2k plus 1. Okay, so square it, you will get 2k square plus 4k plus 1. Okay, so take 4 as common from both of these, you will get 4k into k plus 1, and you will have 1 here. Okay, then if you consider this term k into k plus 1 as k dash, you will be remaining with 4k dash plus 1. Okay, so this is an odd integer. Okay, since we had taken n as odd integer, we got here as n square as odd integer. Okay, so therefore this is the direct proof. Okay, in indirect proof what we'll do is we'll use the contrapositive. Okay, so first define what is p and q. P, n be an odd integer, and q is n square is an odd integer. Okay, so not q conditional not p is, what is not q? N square is an even integer, so that we'll consider first as true. N square is an even integer. I can write n square as 4k square. Okay, so n will be 2k, so 2k is even integer. Okay, so therefore not p is true. What was p here? See, p we had considered as an odd integer, right? So we got here as not p. Okay, so that's what we had to get in contrapositive, and since contrapositive is proven to be true, the given statement conditional is also true. So this is for the indirect proof. In proof by contradiction also it's the same thing. We'll consider p and q, and we will suppose that p conditional q is false. That means p is true and q is false. Okay, and then what we'll be doing is we'll be proving that q is true. Okay, so let's see how to do that. Firstly consider n. N is an odd integer. Okay, so p is true, so n is equal to 2k plus 1, n square is equal to 2k plus 1 whole square. Okay, since q is false, n square is an even integer. Okay, so what's n square? N square is 4k square. Okay, so but according to this we got here n square as 2k plus 1 whole square, and we are getting n as 2k. Okay, so that's a contradiction. That contradiction shows that our assumption that p conditional q is false is invalid. Okay, so by that we can prove that p conditional q is true. In this question we have been asked to prove by mathematical induction that for any positive integer n, phi divides n raised to phi minus n. Okay, phi divides n raised to phi minus n. Now for that first you have to consider p of n, which is phi divides n raised to phi minus n. Now for p of 1, 0 is divisible by 5, so p of 1 is true. Then we will consider p of k. P of k is k raised to 5 minus k, that is divisible by 5, so k raised to 5 minus k can be written as 5m. Now same we will do for k plus 1. Okay, so instead of k we will write here k plus 1 and we will expand it and we will take 5 common here. Okay, since we are able to write the equation by taking 5 as common, it's divisible by 5. Okay, so p of k plus 1 is true, hence p of n is true for all n greater than or equal to 1. Similarly, we have to do for the Fibonacci sequence also. So in the Fibonacci sequence we have been given fn. Okay, for n is equal to 0 we will get as 0, for n is equal to 1 we will get as 1. Now for that we prove the result for n is equal to 0 and 1. We can assume that the p of k is true for all k greater than or equal to 0. Now we have to prove for k plus 1. Okay, so we'll just write what is Fibonacci sequence? The sum of previous two numbers. Okay, so f of k plus 1 can be written as f of k plus f of k minus 1. Okay, so we will be writing the values of both of these separately and then we will be taking in common and also doing some changes here. Like see here what we did is we took the LCM and multiplied the numerator and the denominator by 2. Okay, so we will get this term. Okay, this term we have to get it's compulsory in this step because we have to get 1 plus root 5 by 2 whole square. Okay, so to get that you have to multiply the numerator and the denominator by 2. Okay, so after getting that we will take this as common. See here 1 plus root 5 by 2. These two terms are common here, so the powers will be added. K minus 1 plus 2, that will give us k plus 1. Here also it's the same thing, we will get as k plus 1. So since we are getting the powers as k plus 1, it's the expansion of p of k plus 1. So hence it's true for n is equal to k plus 1. Therefore by mathematical induction p of n is true for all n greater than or equal to 0. Okay, we have been given an equation and it's given that a of n is a multiple of 8. Okay, so for 1 we will test, we will get as 8. Okay, so therefore p of 1 is true. Assume that p of k is true and we have to prove for p of k plus 1. Now what is p of k plus 1? Now a of k plus 1 is equal to, instead of see here in this n place, right, 5 raised to n, we will write 5 raised to k plus 1. Okay, in the same way you will write here minus this one, previous one. Okay, so what we are writing here is a of k plus 1 minus a of k. Okay, so that should be giving us 8. Okay, 8 or 8m because it's a multiple of 8. Okay, so let's see further. Now see when you expand it, okay, expand it and take 5 raised to k as common, you will get here as 4. Okay, and here also you will get 2 into 2 which is 4. Since we got here as 4 and we need a multiple of 8, so we have to observe this. On observation of this term 5 raised to k and 3 raised to k minus 1, see here 5 and 3 both are odd. Okay, so their powers will also be odd. Okay, so if you add two odd numbers, the sum of two odd numbers is always even. Okay, so therefore 5 raised to k plus 3 raised to k minus 1 is an even number. So if it's an even number, it can be written as 2k, right? So 2k multiplied by 4, so you can write as 8k. So from that we will get that it's a multiple of 8. Okay, in this question first we will take p of n. We will write this question here. So for the first step, for p of n, what the given question, write that, and after that p of 1. Okay, after that for p of 1 substitute the value of n as 1 here, find out what you will get in LHS and RHS. Okay, so after that if it's equal, then you'll write p of 1 is true, then write p of k in the same form as n, then prove that prove the same for p of k plus 1. The first k integers will be p of k plus p of k plus 1. Okay, so in the RHS also you will substitute the value of k as k plus 1. Okay, now it's just simplification and you will get LHS and RHS as equal. Okay, so in the final step you will write p of k is true. Okay, this is the formula of permutation and combination. Okay, so the first question is find all the arrangements of the are there for the letters of the word sociological. Okay, so since there are 12 letters in total and 3 O are repeated and 2 C, S, L and C, S and L are repeated, so how we will be writing is how many letters are there, that will be writing that factorial in the numerator, and the denominator what we will be writing how many repeated terms are there, means if 3 O's are repeated, we'll if 3 O's are repeated, we'll write 3 factorial into 2 factorial. for each of C, S and L we will write 2 factorial, 2 factorial, and here one more 2 factorial is there. Okay, since C, S and L all are repeated 2 times. Okay, so this is the final answer after calculation. Okay, continuing the same question we have here, in how many of these arrangements A and G are adjacent. Okay, so since they have asked us for A and G as adjacent, we will take AG as a single unit. Okay, so first we will calculate how many possible ways are there if we take the A and G as single unit. Okay, now here 11 letters are there. Okay, and this many repeated things are there, so these are the total number of ways. Now A and G can be written as AG or GA for each of this combination. Like for AG, if you take AG, you will have this many ways, and if you take GA, again this many ways are possible. Okay, so you will multiply by 2. Okay, so you'll get this final answer here. Further, we have been asked in how many of these arrangements are all the vowels adjacent. Okay, so see here how many vowels are there. 3 O's, 2 I and A. Okay, if we consider all these letters together, since they are to be adjacent, we'll consider it as X. Okay, now after considering it, we'll have the total number of letters as 7. Okay, so we'll be getting the number of ways as 7 factorial by 2 factorial and 2 factorial in the denominator. Why 2 factorial? Because C is repeated twice here, L is repeated twice here. Okay, and this is considered as a single letter, so we'll be considering we'll be not considering what is inside it. Okay, that will be we'll see in the next step. Okay, so after getting this number of ways, then we'll be seeing how many combinations are possible here. Okay, see 3 O's are repeated and 2 I are repeated. Okay, and total number of letters are 6, right? So we'll be writing 6 factorial. Okay, 6 factorial by 3 factorial and 2 factorial, 3 for 3 O's and 2 for 2 I. Okay, so we'll be getting the total number of ways here. Now for each of these combination of letters, we'll have 7 factorial by 2 factorial into 2 factorial ways. Okay, so we'll multiply both of these to get the total number of possible ways. Okay, so these are total number of possible ways. In this question, we have been asked to find how many arrangements of the letters Mississippi have no consecutive S. Okay, means first we'll find how many arrangements of this letter are possible. So there are total 11 letters, and the repetitions are written in the denominator, and we'll get the total number of ways as this. Okay, so after that we have to find how many ways we can arrange so that no S is adjacent. Okay, so what we can write is, see, if we disregard the 4S, means 4 times S is repeated, right? So if we not consider S, only we will consider the remaining letters, 7 letters. How many possible ways are there? This many ways. Okay, so for each of these ways we can place the S. So see here, so we can place the S in between any of these letters. Okay, so 4S can be placed here in the total 8 places, any of these 8 places. So 8 places are possible, and we have to place 4 S. Okay, so that's nothing but the combination, which is 8C4. Okay, from 8 ways you are selecting 4 ways. Okay, so total number of ways possible are 8C4 into how many how many arrangements are possible for the remaining letters is 7 factorial by 4 factorial into 2 factorial. Okay, so if you multiply it, you will get the final answer. Okay, so that's the total number of ways in which S are not in consecutive places. Okay, in this question we have been given that a woman has 11 close relatives. Okay, so among 11 she has to invite 5 for them, 5 for the dinner. Okay, 5 for the dinner. So if in the first case there is no restriction, means in normal way, means 11C5 ways, from 11 you are choosing 5. Okay, so 11C5. In the next case we have been given that 2 particular persons will not attend separately. Okay, either they will attend together or they will not attend. Okay, so that's the second case. So in the second case we have if they both are invited. Okay, so see, from 11 if 2 persons are invited, then the total number of persons remaining is 9, and you have to invite 5 for the dinner, right? 2 are already invited, so total number of people remaining is 3, so the number of ways is 9C3. In similar way, if both are not invited, okay, so if both are not invited, 11 minus 2. Why? Because both will not attend separately. The total number of people who can be invited is 9. Okay, and how many are to be invited for dinner? 5. Okay, so 9C5 ways. Okay, in the third case we have been asked 2 particular persons will not attend together. So they will not attend together means 3 cases are possible. if A is invited, suppose that two persons are A and B, okay, if A is invited, B will not attend. That means if A is invited, means A is invited, so one is gone and B will not come since A is invited. So total number of people remaining are 9, and since we have to invite 5 people, A is invited, total number of people remaining are 4, so 9c4 is the number of ways. Similarly for B also it's 9c4. Then if A and B both aren't invited, means both aren't invited, the number of people remaining are 9, and we have 5 left, 5 people to invite to dinner, okay, so 9c5 ways is the total number of ways, okay. So the combination of all these 3 possible cases will give the total number of ways, okay. In this question we have been given that how many positive integers n can be formed using the digits which they have given here if we want n to exceed 5 million, okay. So 5 followed by 6 zeros. So if the digit which we form has to exceed this number, that means in the first place it should be either 5, 6 or 7, okay. So 3 cases are possible. So in the first case, if we consider here as 5, we will be remaining with 6 digits which are 3, 4, 4, 5, 6, 7, okay. So finding the number of ways, 6 factorial by 2 factorial. Why 2 factorial? Because 4 is repeated twice, okay. So in the similar way we will do for 6 and 7 also, and we will write the total number of ways as sum of the 3 possible scenarios, okay. So that's the total number of ways. In this question we have been given that question paper has 3 parts, so total number of questions which we have to attend is 7, okay, at least 2 from each part. So A has 4 questions, B has 5 questions, C has 6 questions, okay. So if you have to attend 2 from each part, how many questions are to be attended? Altogether 6. So we have a choice for 1 question, okay. That 1 question remaining can be chosen either from A, B or C, okay. So separately we will write the cases. If we choose from A, okay, so what will be the case? If we choose from A, we are attempting 3 questions from A, 2 from B and 2 from C, okay. So from A you will have 4c3, B you will have 5c2, and C you will have 6c2. Similarly if you choose from B, okay, so 3 from B, so in that case you will write 5c3, means total number of questions 5, you are choosing to attempt 3 from B, means 5c3, okay. So in that way the third case is 3 from C, means total number of questions are 6, from that you are choosing to attempt 3, okay. So in the last case you will have 6c3. You will calculate all of these and add together to get the total number of ways, okay. Before moving on with the binomial and multinomial theorem, remember these formulas, okay. So we will be using these formulas. Now see here, the first question is we have to find the coefficient of x power 9 and y cube in the expansion of this term, okay. So this is the binomial theorem because 2 terms are given, so we have to use the binomial theorem formula. So we will write here, we have been given raised to 12, so n is equal to 12, okay. We have to find the value of r. Now r, how we will find? Write the formula here, and instead of x we have 2x here, so substitute that, and instead of y we have minus 3y, and write that as well. And then we have here raised to r and raised to n minus r. N value is known 12, so we will write here 2x raised to r into minus 3y raised to 12 minus r. Now in the question they have asked us for x power 9 and y cube, so we will be equating 9 with r and 3 with 12 minus r. So by that we will get the value of r, and by using that value we will find the coefficient, okay. nr is nothing but ncr, okay. So the final coefficient will be written as 12c9 from this, and 2 power 9, okay, and minus 3 power 3, okay. So this will get the final coefficient. In this question we have to find the coefficient of x power 12 in the expansion of this term, okay. See here, observe here, x cube is also there, so we will be taking x cube at last. First we will expand this, okay. So by using the formula we have the n value as 10 here, and we have to find the value of r, okay. So the r's value will be found by comparison with what they have given in the question, okay. So we have to find the value of x power 12. So see here, the expansion of 1 minus 2x raised to 10 is this, but in the question they have x cube also, right? So we will multiply x cube here also, okay. when we will multiply x cube here, we will get as x power r plus 3. Okay, before it was x power r, right? When we multiply x cube here, we will get x power r plus 3. Okay, on comparison, what we will get is x power r plus 3 is equal to x power 12 from the question, and by using this formula, we will get the coefficient of it. Okay, this question we have to use the multinomial theorem. Okay, so 4 terms are given for us, and each of these powers have been given. We have to find the coefficient of this term. Okay, so for that, using this 5 terms here, see here we have in the coefficient 4 terms, but here we have 5 terms because one is constant here, 5. Okay, so that will not be considered in the variables. Okay, so that's why this 5 is not mentioned here. Okay, so after that, we'll be writing the formula, which is 16 will get from what's the power of the main term, and n1 to n5 means 5 terms are there, right? So the powers of 5 terms will be written in this form, and we will be comparing this with the term which they have given. Okay, so a power n1, see a power 2, so n1 is 2. Okay, in that we will find all of these values, and after we get all of these values, we have to expand this one. Okay, so this one is nothing but 16 factorial by what are the n values, those factorials in the denominator. Okay, we will get 2 power 8, 3 square and 5 power 4 from this one. Okay, see here it's 2b power n2. Okay, so 2 power n2 will also be considered in the coefficients, right? So that will be writing here, the n2's value will find and raise it to the power of 2, and similarly for 3 and 5. Okay, so after the calculation we will get the final answer. Coming to combination with repetitions, we will be given the question of this type: in how many ways can we distribute 10 identical? Okay, if they give identical, that means you have to use this formula. Okay, so 10 identical balls, marbles among 6 distinct containers. So you will have two things first. You will have item and the places. Okay, places will be this one, means 6 distinct containers, and the marbles which are the items which that will be r. Okay, and one more thing you can do to know what is r and n. R will be always greater than n. So in this case 10 is greater than 6, right? So r is 10 and n is 6. Okay, so after knowing that, you have to apply this formula, C of n plus r minus 1 comma r. This is the combination formula. So we will be applying this formula here, C of n plus r minus 1 comma r. So r plus n minus 1, that is 15, and r is 10. So we will be writing 15c10. In how many ways can we distribute 8 identical balls into 4 distinct containers? So 8 is greater than 4, so r is equal to 8 and n is equal to 4. Okay, now since we got this, we have to apply the formula. Now in the first case, they have asked us to find the number of ways when no container is left empty. That means each container should be filled with one ball at least. Okay, so if we fill each container with one ball, 4 balls will be used, so the remaining balls will be 4. Okay, so r and n both will be 4, and by using this value of r and n, apply that in this formula, n plus r minus 1 comma r, then you will get the final number of ways. In the next question, they have asked us the 4th container gets an odd number of balls. Okay, so suppose that there are 4 containers here. See here, 1st, 2nd, 3rd, 4th. Okay, so it should get the odd number of balls, means it can get either 1 ball, 3 ball, 5 ball or 7 balls. Okay, so in each of these cases we will be calculating. In first case, if it gets 1 ball here, okay, so remaining balls will be 7, and 7 will be distributed among 3 containers. So in that case, n will be the value which is 3. Okay, it will be always same, and r will be how many balls are to be distributed. Since 1 is gone, the number of balls will be 7. So by using this n and r value, we will calculate. For the second case, see here, for the second case, if 3 balls are used, so 8 minus 3 is 5, so r will be 5. By using n is equal to 3 and r is equal to 5, you will find the number of ways. Okay, so for all of that 4 cases, we will be doing that and calculating the final result as the sum of all these possible ways. Okay, so the sum will give us the final answer. In this question, we have been asked that we have been given that there are 6 persons, A, B, C, D, E, F. Okay, so A and B will be getting 4 prizes, means they'll be getting prizes which does not exceed 4. Okay, together, so they can get either 0, 1, 2 or 3. Okay, 3 or 4. Okay, so these are the possible number of ways 0 to 4. Okay, A and B can get, and the remaining will be distributed among these 4. Okay, so what we can do is, in this question we can consider A and B as distinct places and the number of items as R. So consider this as 2 items A and 2 places A and B. We have to distribute 4 means R can be in between 0 and 4. So we have to distribute R number of items between A and B. So the formula is A and B means n is equal to 2 places, and R is equal to, we will consider it as R only now. Okay, so we will be finding n plus R minus 1 C of n plus R minus 1 comma R. So we will be getting here as R plus 1. Okay, so the remaining number of boxes can be given to C, D, E or F. Okay, so if we consider C, D, E and F as 4 places, n will be 4 and the number of boxes will be 10 minus R. Okay, and we will be using that and writing this formula here. Now R can take the values from 0 to 4, right? So the multiplication will give us the total number of ways for R. Okay, and R can take the values from 0 to 4, so the final number will be the summation of R. Okay, from 0 to 4. In this question we have been given that there are 4 persons A, B, C and D. Okay, and the total number of and the total money is 10,000. Okay, so in the multiples of 1000 we have to distribute. So total number of units will be 10. Okay, so 10 units will be distributed among 4 people. Okay, now n is equal to 4 n is equal to 4 because 4 people are there, and R is equal to 10 units are to be distributed. Okay, so by using this we can find out the number of ways. That's for the first case if there is no restriction. If every one of these should receive at least ₹1000, which means 1 unit, that means 4 people are there, right? From 10 units 4 units will be cut and given to the 4 people, and will be remaining with 6 units. Okay, so 6 units has to be distributed among 4 people. So n is equal to 4 and R is equal to 6. Okay, everyone has to receive at least 1000 and A in particular should receive at least 5000. Okay, so if 3 of those receive 1000, that means from 10 we have to deduct 3, then A should receive at least 5000, means A should get 5000. Okay, so the remaining will be 2000, which means 2 units. Now 2 units has to be distributed among 4 people, that means n is equal to 4 and R is equal to 2. Okay, so by using that formula we will get the total number of ways. In this question we have been given the value of f of x for x is greater than and less than 0. Okay, so in both of these cases we will apply different formula. So for the first one, f of 5 by 3, for f is 5 by 3 we will get we'll use this formula 3x minus 5. Okay, it's greater than 0. So for greater than 0, the formula used is 3x minus 5. Okay, so we'll be applying the value of x as 5 by 3 and calculating the final answer. Now in the second question we have been given that find the f inverse of minus 5 comma 5. Okay, so this is the closed interval, that means minus 5 and 5 both are considered. Okay, so for 2 cases we will consider if x is greater than 0, then f of x is 3x minus 5. Okay, minus 5 and 5 in between both f of x, which is 3x minus 5 will be used. Okay, then we'll add 5 throughout because we need just x here. Okay, so for getting x here we'll add 5 first, so 5 will be cut, then we'll divide by 3. Okay, so x will be remaining here. Now by when x is remaining here, we'll get the term as 0 less than or equal to x less than or equal to 10 by 3. Okay, now that was when x is greater than 0. Now for the same thing we'll do for x is less than or equal to 0. So this is the formula we will be applying here, adding minus 1 throughout and dividing by minus 3, then we'll be getting this interval. Observing these both intervals, we'll be getting the final interval as minus 4 comma 3 minus 4 by 3 comma 10 by 3. Okay, in this question we have been given 2 sets A and B. Okay, and we have to find how many functions are there from A to B. Okay, so the formula is n raised to m. Okay, m is the number of elements in A and n is the number of elements in B. Just apply the formula, you will get this answer. Similarly, we have to do for how many of these functions are 1 to 1. For 1 to 1, the formula is n factorial by n minus m factorial. Okay. Then in the third case, we have been asked how many are onto functions. Okay, onto function is not possible because the number of elements in A should be greater than B. Okay, then only onto is possible. So in this case, onto is not possible. Okay, how many functions are possible from B to A? So for B to A, you will have m raised to n. Okay, which is number of elements in A raised to number of elements in B. Okay, so you will get this answer here, and the number of 1 to 1 functions is 0 because B should be lesser than A, then only 1 to 1 function is possible, as in the previous case. Okay, see here, in the previous case A was less than B, right? So this 1 to 1 was possible, but onto was not possible. In this case B is greater than A, so 1 to 1 is not possible, but onto is possible. So when you consider onto, the formula is this: summation of k is equal to 0 to n, which is 4 minus 1 power k 4c 4 minus k, and in brackets 4 minus k raised to n. Applying this and finding the summation, we will get this answer here. In this question, we have been given a set A and we have to define a relation R on A cross A by the following rule. Okay, which means x1 plus y1 is equal to x2 plus y2. Then these both are in a relation. Okay, so for the first thing, what we will do, we have been asked to verify that R is an equivalence relation. For equivalence relation, first we will have to prove that R is reflexive. Okay, so for R is reflexive, what we will write: x comma y belongs to A cross A. Okay, so x plus y is equal to x plus y. We can write R is reflexive. Okay, in the next case, we will consider two terms, which is x1 y1 and x2 y2. Okay, since x1 plus y1 is equal to x2 plus y2 and x2 plus y2 is equal to x1 plus y1, these both are same, so R is symmetric. Then in the third case, we will consider three items, which is x1 y1, x2 y2, then x2 y2 and x3 y3. So x1 plus y1 is equal to x2 plus y2 for this one, and for this one it is x2 plus y2 is equal to x3 plus y3. We can conclude that x1 plus y1 is equal to x3 plus y3. That means x1 y1 is in relation with x3 y3. Okay, so R is transitive. Therefore, when R is reflexive, symmetric and transitive, that means R is a equivalence relation on A cross A. Okay, that was the first part of the question. In the second part, we have to find the equivalence classes of 1, 3 and 2, 4. So what's the rule given here? x1 plus y1 is equal to x2 plus y2. So for 1, 3, which all numbers have the same sum as 1, 3, which means 1 plus 3 is 4, right? So the other terms which can be possible are 2 and 2. 2 plus 2 is also 4. 3 plus 1 is also 4. So the equivalence classes will be 1, 3, 2, 2 and 3, 1. Okay, so in the similar way, for 2, 4, the possible classes are these. Okay, in this question we have been given a set A and A are B if and only if A divides B. Okay, so we will be selecting two elements from it and checking if A divides B or not. If it divides, that will be included in the relation. Okay, in that way we will get the all the elements here. In the first question we have to prove that R is a partial order on A. Okay, for that what we will do, first we have to for proving R is a partial order, we have to prove that R is reflexive, antisymmetric and transitive. So R is reflexive since A divides A. Okay, so for antisymmetric, what we will do, see, if A comma B belongs to R, means if A divides B, B should not divide A, then only it can be called as antisymmetric. But if B divides A, then the only possibility is A and B are equal. Okay, so that's what antisymmetric is. By observation, we can find that it's true for all these elements. So hence R is antisymmetric. Then transitive. See, if A divides B and B divides C, okay, that means obviously A also divides C, right? So R is transitive. So therefore, we can write that R is a partial order on A. Okay. In the next question, we have been asked to draw the Hasse diagram and write down the matrix of the relation. Okay. So for Hasse diagram, what we will do, first write how many elements are there. Means, see here, the elements here are A. Okay, the set A, which is 1, 2, 3, 4, 6 and 12. Okay, so we'll be writing here first the least element. Okay, and one is related to 2, then in the next level 1 is related to 3, right? So in that way we will be continuing, okay, means 3 is related to 6, and 2 is connected to 6, and 4 also. So in that way you will be increasing levels, okay. For the max element you will write in the top, and for the matrix of this for the matrix graph, what you will do, you will write these elements here 1 2 3 4 6 12, okay. In the columns also you will write the same, and if there is a relation between 1 and 1, you have to see this relation here, 1 comma 1 belongs, so 1 and 1 has a relation, 1 and 2, 1 and 3, like that. 2 and 1 doesn't have, right? So in this case, see here, this is 2 and 1, it's 0 here, because 2 and 1 does not have a relation, and 1 and 1 have a relation, right? So 1 and 1 will have 1 here. So where all these terms are present, those terms in the matrix will be made as 1, okay. Rest all will be filled with 0. That's the matrix of a relation, okay. In this question we have been given the Hasse diagram, and we have to find out the upper bounds of B, okay. So B is given as 3 4 and 5, okay. So what is the upper bound? Upper bound means all the elements in the upper part should be related to 3 4 and 5, okay. So those elements are 6 7 and 8, okay. Since 3 of these are related to 3 4 and 5, so the upper bound of 3 4 and 5 is 6 7 and 8, okay. And the lower bound means the elements lower than this one which are related to the set B, okay. So those elements are 1 2 and 3. 3 is also included because since 3 has the connection with 4 and 5, okay. So 3 will be considered. In the next question we have been asked least upper bound of B. See, the upper bounds are 6 7 and 8, okay. So if you have to consider least, it should be a unique element, but in this case 6 and 7 both are at the same level. So in this case, since 2 elements are there, there is no least upper bound, okay. In the similar way, greatest lower bound is a unique element. That means what are the lower bounds? See here, 1 2 and 3. So the greatest one is 3 here, right, and it's unique. So the greatest lower bound is 3. In this question we have been given f and g, okay. F is from A to B and g is from B to C. These are invertible. That means f can be written as f inverse also, and g can be written as g inverse also. We have to prove that g of f which is from A to C is also invertible. For that, what we will do, since f and g both are invertible, 1 to 1 and onto, consequently g of f is both 1 to 1 and onto, okay. This is one law. If f and g both are onto and 1 1, g of f is also onto and 1 1. When a function is onto and 1 1, that means it's invertible, okay. So g of f is invertible. Next we have to prove g of f inverse is equal to f inverse o g inverse, okay. So for that, what we will write, we will consider g inverse as h, okay. H means C to A, okay. Since g of f is A to C, we will consider h as its inverse and write as C to A, okay. So we will have to prove g of f of h is equivalent to h of g of f, okay. If these both are proved to be the same, then the function g of f is invertible. Here we have f o f inverse, that means f of f inverse, okay. See here, in f inverse is defined from B to A, right. So you will be entering the value of B here, and f inverse of B is A, and what is f of A? That is B, okay. Since you inserted the value of B here and got the output as B, that means it's an identity function, okay. So you'll write f o f inverse as IB, okay. So therefore when you consider it as 1, you'll get g o g inverse. Similarly, g o g inverse is IC, okay. In a similar way you will do for this one. First you will consider g o g inverse and then f inverse o f, okay. Then you will get here as IA. Therefore if in both cases you get IC and IA, then that shows that g o f is the inverse of this one h, okay. So what was h? f inverse o g inverse, okay. F inverse o g inverse. So therefore g o f inverse is equal to h, which is equal to f inverse o g inverse. In this question we have been given f of x and g of x, okay. Ax plus b and g of x is 1 minus x plus x square, and g of f has been given, okay. So in first case, what we will do, we will write this g of f as g of f of x. Okay, so what is f of x? Ax plus b. What is g of ax plus b? In this terms, wherever x is there, substitute that as ax plus b. Okay, so you will be getting this term here. Now this term is equivalent to this term. Now compare the coefficients. We will be getting two values of a here, which is minus 3 and 3. Now when you consider b as when you consider a as minus 3, you will be getting b as 2. Okay, and when you consider a as 3, you will be getting the value of b as minus 1. Okay, so these are the two required solutions. Okay, in this question we have been given a triangle and we are joining the midpoints of it, and we have to prove that if we select 5 points, any of these triangle will have at least 2 points. Okay, if you have to place 5 points inside these 4 triangles, that means any one of the triangle will have at least 2 points, right? Means if you consider 4 in separate, then another point will have to be placed among any of these. Okay, so any of these will have at least 2 points. Okay, so that's what we have to prove in this question. In this question we have been given that from a set of 29 persons, at least 5 persons must have been born on the same day of the week. Okay, so suppose that there are 29 persons, which is m, and the number of days in a week are 7. Okay, so the formula is p is equal to m minus 1 comma n. Applying these values we will get p as 4. Okay, now for pigeonhole principle you have to have at least p plus 1 or more. That means 4 plus 1, which is 5. 5 or more people must have been born on the same day. Okay, so we will get the final answer here as 5. Okay, in this question we have been given that if 30 dictionaries contain this many pages, then at least one of the dictionary must have at least 2045 pages. Okay, so this is m and this is n, and we have to find out p first, then p plus 1 or more. Okay, that is 2045. In this question we have been given that from 13 clerks, at least 2 of the clerks will have the birthday during the same month. See, total number of months are 12. Okay, and the clerks are 13. So even if the first 12 members have different birthday months, the 13th person should have the birthday which is among the 12 months. Okay, so 2 persons will have the birthday on the same month. Okay, so here m is equal to 13 and n is equal to 12. So p you will get as 1, and for pigeonhole principle you have to use p plus 1 or more. That means 2 or more persons will have the birthday during the same month. In this question we have to determine the number of positive integers n, which is between 1 and 100, and n is not divisible by 2, 3 or 5. Okay, so see here, for the total number of elements in the set are 100. Okay, from 1 to 100, then that means s naught is 100. Now we have to calculate s1. Okay, so for s1 what we will do, let a be the total numbers divisible by 2. Similarly for 3 and 5 you will have the sets b and c. Okay, our task is to find how many numbers are not divisible by 2, 3 and 5. Okay, so we will take a bar, b bar and c bar, that is equivalent to a union b union c whole bar. Okay, in the first case we have to find out from a, b and c sets how many are divisible by 2, 3 and 5. Okay, for 2 you will divide the total number of elements by 2, then we will get the total number of elements divisible by 2, that is 50. If we get in decimal, we will consider the lower number, which is in this case 33. Okay, then for 5 you will get as 20. Now what is s1? S1 is nothing but the sum of a, b and c which we got here, that is 103. Now similarly we will find for s2. For that first we will find a intersection b. What is a intersection b? Total number of elements in s which are divisible by both 2 and 3. Okay, that means 6. Okay, so the total number of elements divisible by 6 are 100 by 6, which is 16. Similarly for a and c, finding the sum will give us the value of s2. Now a, b and c, how many numbers are divisible by both a, b and c? That means we have to find out the LCM of 2, 3 and 5. That means the LCM is 30. Okay, so the total number of elements divisible by 30 are 100 by 30, which is 3. Okay, so s3 also we got. After getting s0 to s3, we will be writing the formula here. A intersection b intersection c, a intersection b intersection c is equal to s0 minus s1 plus S2 minus S3. Okay, so we'll be just using those values to find out to get the final answer. Okay, to get the final answer. The next question is the continuation of the previous one, which is to determine how many are at least divisible by divisible by 2 of the 2 of 2, 3 or 5. Okay, so if you get this question of this type, at least we have to use LM formula. Okay, this is the LM formula, and n value and m value is the L is 2 because we have been asked at least 2 of 2, 3 or 5. Okay, so L2 we have to find out, and by using the value of L2 we will write first Sm. See, m is 2, right? So S2 will be written here minus m and m minus 1, which is m is 2, 2 minus 1 is 1, so 2 and 1 will be written, and S3 m plus 1. Since we have till S3 only, we will not continue further. Okay, so this is the term which we need for the least elements. In the next question, we have been asked to find out how many are exactly divisible by 2 of 2, 3 or 5. Okay, so in this case em will be used, em formula. In em formula we have been asked to find out at least 2, right? At least 2 of 2, 3 or 5. So m will be 2, and substituting the values of S2 and S3 to get the final answer here. In this question we have been asked to find out how many of the 26 letters can be arranged so that none of the patterns car, dog, pun or bite occurs. Okay, so firstly we will be writing what is S0. Okay, S0 means how many total number of permutations are possible. Since there are 26 letters, the total number of permutations are 26 factorial. Okay, so next what we have to do is, for each of these letters we will form a set which is A1, A2, A3 and A4. Okay, now see for car here, if we remove 3 letters from 26, we will be remaining with 23 letters. Okay, so along with 23 letters, if we consider CAR as one unit, that means 24 possible entities are there, and the total number of ways of arranging these are 24 factorial. In the second part, for finding S2, we will consider 2 at a time. Car and dog will be considered as separate units. Okay, so if they are considered as separate units, that means total number of letters are 22. Okay, so 22 factorial. By applying this formula, which is S0 minus S1 plus S2 minus S3 plus S4. Okay, so applying that formula, you will get the final answer here. Similarly, in this question we have been given the letters spin, game, path or net. Okay, so in this case also same thing you will do. First find S0, then A1 will be considered for spin, and then S1 will be calculated for the four words, and then for S2 you will consider 2 words at a time. Okay, so see here, when we consider spin and path together, see here, spin and path. Okay, in spin already P is taken, so we can't form the word path. Okay, so total number of ways is 0 here. Then in the similar way, spin and net. Okay, but spin and net can be formed as by taking n as a single term. Okay, so this term is possible. So in that way we will get the total number of ways, 6 letters if we take common, and this as one word, then the total number of ways will be 21 factorial. Okay, in that way we will calculate the value of S2, and S3 and S4 are 0, and the required number will be S0 minus S1 plus S2 minus S3 plus S4. Okay, in this question we have been given that there are total number of 30 students, and 15 study history, 8 study economics and 6 study geography. Okay, and it's known that 3 students study all these subjects, and we have to show that 7 or more students study none of these subjects. Okay, so first we will consider what is S0. S0 means total number of students, which is 30. Then what is S1? S1 means total number of people who study the single subjects, which is 15 study history, 8 study economics and 6 study geography. So 15 plus 8 plus 6 will give the value of S1. Okay, will give the value of S1, which is 29. S2 is not known because they have not given how many study 2 subjects together. Okay, but we have been given 3 students study all these subjects. Okay, so S3 will be 3. Now we have to prove that at least 7 or more students study none of these subjects. Okay, so for that the formula will be used. which is a1 bar intersection a2 bar intersection a3 bar, that is nothing but s0 minus s1 plus s2 minus s3. Okay, since we know the value of s0, s1 and s3, we'll write this and we'll simplify it and we get the equation as s2 minus 2. Okay, so this will be anyway greater than this. Okay, so that is 3 into 3, which is 9. Okay, so at least 9 will be there. Okay, s2 will be at least 9 or more. Now since we got the value of s2 as greater than or equal to 9, so we will be using this value here in this equation, s2 minus 2. Okay, so s2's value is greater than or equal to 9, so 9 minus 2 is 7, so therefore the final answer is greater than or equal to 7. Okay, so that's what we have to prove here. 7 or more students study none of these subjects. Okay, coming to derangements, before moving on, I would like to explain you what is derangements. Okay, see here, consider these numbers here, 1, 2, 3 and 4. Okay, now see, the place of 1 is here and 2, 3 and 4 here. Okay, now derangement means we have to place 1 in either of these 3, okay, and 2 in either of this or this. Okay, means how many arrangements are possible in which the numbers present here will not be in their natural place. Okay, means 2 should not be present here, 3 will not be present here. In that way, how many arrangements are possible is nothing but the number of derangements. The right gloves are distributed to the students at random, and then the left gloves are distributed. So the question is, no child gets a matching pair, means all the gloves are of different colors. Okay, so if no child is to get a matching pair, that means total number of ways are, see here, since there are n gloves, the number of arrangements will be n factorial, and finding the probability we will get dn by n factorial. Okay, so n factorial will be cancelled here, we will be remaining with this term. Okay, so this is the value of p1. In the second part, we have been asked that in how many ways every child will get a matching pair. Okay, since there is only one way for that every child will get one matching pair, the probability will be 1 by n factorial. This is the total number of ways, and 1 is the number of ways in which each child will get the matching pair. Okay, in the next question we have been asked that exactly one child will get a matching pair. Now in the first question we found by dn, means if there are n gloves, no child will get a matching pair, means dn. Okay, if one child should get, an exception to this is dn minus 1. Okay, so we will be writing here dn minus 1. Okay, dn minus 1 by n factorial, that is p3. Now in the fourth question we have been asked that at least 2 child get matching pair, that means the possibilities of no child getting matching pair and one child getting matching pair should not occur. Okay, that means p1 and p3 should not occur, that means the probability will be 1 minus p1 plus p3. Okay, in this question we have been asked that we have to find the number of derangements from 1 to 2n satisfying that the first n places are 1 to n in some order. Okay, so see here, two cases are possible, first 1 to n and n plus 1 to 2n. Okay, so the derangements possible are dn, since n elements are there, and the derangements here are, and the derangements possible here are also dn. Okay, since n elements are there. Okay, now in the second part we have been asked that from n plus 1 to 2n in some order, first n places will be filled with n plus 1 to 2n. Okay, so there are n digits here, and 1 to n will be filled in the remaining last digits. Okay, so the total number of ways will be n factorial. It will not be dn because anyway n plus 1 to 2n, the first n places are not their natural places, so it will be the permutation only, normal. Okay, normal arrangement. Okay, means in the first n places n plus 1 to 2n means n digits will be filled in n factorial ways. Similarly for the rest n digits also. Okay, in this question we have been asked that there are 8 letters and 8 people to which the letters are to be delivered, and we have to find out that at least one person should get the right letter. Okay, but, how many number of ways are there, that we have to find out. So for that first we will find out total number of ways. Okay, means 8 letters should be delivered to 8 number of people, that is 8 factorial ways. Okay, and you have to subtract with no letter should get to the right person. Okay, that is D8 derangement. So when we subtract this total number of ways minus no person gets, will get the number of ways in which at least one person will get the right letter. Okay, in this question we have been asked to find out the number of derangements of 1, 2, 3 and 4, and since there are 4 digits we have to find D4, and by applying the formula we will get the final answer here. Okay, in this question we have been asked to find out the root polynomial for 3 cos 3 board using the expansion formula. Okay, so first we will consider 5 as the marked term. Okay, so if you consider 5 as the marked term, remove the rows and the column, you will be remaining with 1, 3, 7 and 9. Okay, so that will be considered as D. We will be getting E by not considering the marked letter, which is 5. Okay, so this is E. For each of these we will find what is the root polynomial. Okay, so in this case R1 and R2 will be found, and we'll find RDX. Then similarly for the board E also, then by multiplying we will get RCX, which is for the final board. Okay, for this board we will get the final root polynomial that will give us the final answer. Okay, in this question we have been asked to find out the root polynomial for the shaded chessboard. Okay, so there are 4 terms here, so R1 will be 4 and R2 will be 3, so RCX will be 1 plus 4x plus 3x square. Okay, so in my theory part of the video I have explained in detail how to find out the root polynomial. Okay, so if you want you can refer that. In this question we have been given that 5 teachers T1 to T5 are to be made class teachers for the 5 classes C1 to C5. Okay, so exceptions are given as T1 and T2 do not wish to become class teachers for C1 or C2, and similar exceptions are given. So what we will do is first we will make the rows and columns. Okay, see here, the classes will be taken as columns and the teachers will be taken as rows, and the exceptions given are, see here, for example the first one, it's given that T1 and T2 will, do not wish to become class teachers for C1 or C2. Okay, so the T1 and T2 will not become class teachers for C1 and C2, so those boxes will be shaded, and similarly for the other exceptions also. Okay, so after doing that we will consider 2 boards here, C and D. Okay, this will be considered as single board. Then after considering both as single board, you will find out the values of RCX. Okay, root polynomial. Then after getting both of these values of root polynomial, we will be multiplying it. Okay, so after multiplying we will get the root polynomial for the main board. Okay, now after getting that you have to observe here carefully, this is R1, R2, R3, R4 and R5. Note down these values from R1 to R5, and then you will get then you have to find out S0 to S5. How? This is 5 factorial, the number of ways means 5 is the number of columns, right? So that columns you will take here 5 factorial, then 5 minus 1, 5 minus 2, like that till 5 minus 5. Then here you will have 5 factorial, then here you will have 5 minus 1 factorial into R1, which is 11. See here these values 11, 40, 56, 28 and 4 will be applied here, 11, 40, 56. So this will give the S0 to S5 values. Okay, after obtaining these values you have to add it. Okay, means S0 minus S1 plus S2 minus S3 plus S4 minus S5. Okay, that will give us the final answer. In this question we have been given that bank pays certain percent of interest on the deposits every 3 months. Okay, that means if annual interest is X percent, that means for every 3 months it will be X by 4%. Okay, that means X by 400. Okay, then if the deposit doubles in 6 years and 6 months, what will be the annual percent of interest? Okay, so that we have to find out. Now let P0 be the deposit made initially. Okay, so and Pn be the value of the deposit at the end of nth quarter. Okay, then what is Pn plus 1? That means the value at the next quarter, that can be calculated as Pn plus X by 400 plus X by 400 into Pn. Okay, so X by 4% of Pn plus what is with you, which is Pn, that will give the value you will be getting at the next quarter. Okay, so this is the general reconciliation. So the solution for this reconciliation is Pn is equal to 1 plus x by 400 raised to n p naught. Okay, so if you want to know about reconciliation, refer my theory video. I have explained in detail. Okay, so I will get this general solution here. After getting that, we have been given that after 6 years and 6 months the deposit doubles. Okay, so Pn is equal to 2 times p naught. P naught is the initial value, Pn is the doubled value. Okay, when n is equal to 26, means in 6 years and 6 months there are 26 quarters. Okay, so n is equal to 26. Now by applying this value of 26 here, after applying this value and simplifying it, we will get the annual interest rate as 10.8%. In this question we have been given that the number of virus affected files in a system are 1000. That means a naught is 1000 initially, then it increases every 250%. Okay, so if an is the affected files after 2n hours, then after 2n hours the number of increase will be an into 250%, an into 250%. Okay, so we are adding this one increase with the initial value. Okay, so that will give us the number of affected files after 2n hours. Okay, so by simplifying this we will get an into 3.5. now this is the reconciliation, and the general solution will be an is equal to 3.5 raised to n into a naught. Okay, so a naught we know, and so a naught value is 1000, and here it will be the same 3.5 raised to n. Okay, now we have to find out how many affected files will be there after 1 day. 1 day means 24 hours. Since we are considering 2 hours at 2 hours as n, that means n should be 12, right, for 24 hours. So we'll be using this value, n is equal to 12, n is equal to 12 in this equation, and we'll be calculating the final value. Okay, in this question we have to solve the reconciliation an plus an minus 1 minus 6 an minus 2. Okay, so we have been given two conditions, a naught and a1. Now what are the coefficients of an minus 1 and an minus 2? So the coefficients are 1, 1 and minus 6. Okay, applying these equations and finding out the roots, we will get the roots here. Okay, we will get the roots as minus 3 and 2. Now writing the general solution, which is a into k1 raised to n plus b into k2 raised to m. Okay, in that we will get the general solution. We will find out what are the values of a and b. How we will find out? By using the value of n here. Okay, we have been given a0, that means n is 0. So in this equation we will be using the value of n as 0 and m as 0. Okay, so when we use n and m as 0, we will be getting the so we will get a naught is equal to a plus b. Similarly, we will use n as 1 in this equation, and we will get the value of a1 as this one, minus 3a plus 2b. Now solving these both equation, we get the values of a and b. Okay, after getting values of a and b, which is minus 2 and 1, we will be substituting those values in this an equation. Okay, first we will find out what are the coefficients. In this case the coefficients are 1, minus 1 and minus 1. So we will be writing the equation, which is k square minus k minus 1. Okay, then find out the roots, and by using this we will find out the values of a and b by substituting the initial values, which is f0 and f1, 0 and 1, and by solving this we will get the values of a and b. Using the values of a and b which you got, we will write the final equation here. Okay, in the same way we have been given this equation here, and we will be finding the coefficients and finding out the roots of this equation. In this case we got the root as b by 2 into 1 plus or minus I root 3. Okay, so when we get that roots, we will use this formula for writing a and b. Okay, and we will be also calculating the value of theta. The value of theta is tan inverse of q by p. Okay, so in this case q is is root 3 and p is 1. Okay, so in that way we'll get the value of theta, and we have two conditions here, which is d1 and d2, and by using the values of n as 1 and 2, we'll be getting what is a and b. Okay, after getting a and b, we'll substitute it back in the final equation. Okay, in this question we have been asked to find out whether the following graphs are isomorphic or not. Okay, so in this case, see here, u1 and v1. Okay, for isomorphism you have to prove two things. First is the correspondence between the vertices and the correspondence between the edges. Okay, here the correspondence between the vertices is u1 and v1, u2 and v4, u3 and v5, and so on. Okay, similarly we have to write the correspondence between the edges also. Okay, we have to write at last that the two graphs are isomorphic. Okay, similarly for this also. In this case it's not isomorphic because see here, in the first graph, observe carefully this vertex and this vertex. Okay, the degree is 4 here and the degree is 4 here, and there are no other vertex which have the degree 4. But in this case you will get three vertices having the degree 4. Okay, so in this case, if if a change is observed like this, if a change like this is observed, that means the two graphs are not isomorphic. Okay, in this question there is a mistake in the printing. The diagram is actually like this. Okay, so we have to prove that these two graphs are isomorphic. Okay, so in this case the correspondence I have written here and the edges I have written here, and that proves the isomorphism. Okay, now since this diagram is a bit complex, now let's see how to approach the questions regarding isomorphism. Okay, now see these two graphs are given. Okay, now in the first case, observe here, there is a square here. Okay, so 4 points are connected together. Now find out in this graph which 4 points are connected together. Now on finding out, you'll find that C, E, B and F, these all are connected together. Okay, so the first step what you can do is just expand this. Means see here, take this F here and take this E here. Okay, when you take F and E here, this graph will be in this way. Now after that, take this C and B downwards and E and F upwards. Okay, when you take that, you will get this graph. Okay, now bring this D here and A here. Okay, when you bring both of this here, you will get the graph in this way. Okay, so this graph is similar to what we have been asked in the question. Okay, so in this way you can find out the corresponding vertices easily then. Okay, like W with E, X with C, although it differs according to the different graphs, but try to see if it's possible. It will be the task will be easier then. Okay, so next, in this question we have been given two circles, and in these circles you can observe here, in between both of these there is one gap, but in this graph you have no gap here. Okay, so the adjacency is not preserved, hence the two graphs are not isomorphic. Okay, now we have to show that these two graphs are isomorphic. In these two graphs, the correspondence between the vertices is same, u1 and v1, u2 and v2, so on. Okay, and the edges is also written in a similar way, and this is the same graph which was in the previous question, and in this question also the correspondence between the vertices is u1 and v1 and u1 and v2 and u2 and so on. Okay, in these two graphs, the upper part A, B, C, D is here mentioned as A dash, B dash, C dash and D dash. Okay, and the lower part P, Q, R, S is mentioned as P dash, Q dash, R dash and S dash. Okay, in this question we have been given that there is a simple graph with m edges and n vertices. Okay, we have to prove that m is less than or equal to half n into n minus 1. So each edge, see here, each edge will have two vertices. Okay, so for each edge there is a pair of vertices. Okay, so the number of edges can't exceed the number of pairs of vertices. Okay, now pairs means two vertex. Okay, so if there are n number of vertices, how many ways you can choose? Two pairs. Okay, that means nc2. Okay, so nc2 will give the value half n into n minus 1. So this number is always greater than the number of edges. Okay, since the number of edges can't exceed the number of pair of vertices, so we can write m is less than or equal to half n into n minus 1. For the next question, we have to find out for a complete graph kn. Okay, for a complete graph, there will be exactly one edge between every pair of vertices. So therefore, the total number of vertices will be half n into n minus 1. Okay. In the next question, we have been asked to find out how many vertices and edges are there for k 4,7 and k 7,11. Okay, so what is k 4,7? If the number of edges have to be found, it will be the product, and if the number of vertices have to be found, it will be the sum. Okay, so in this question we have been asked to prove that a tree with n vertices will have n minus 1 edges. Okay, so suppose that this is a tree and this continued here also, but I am not making the whole diagram. Okay, so consider this tree as t1 and t2. Okay, so t1 and t2 are here, and now there is an edge between each of these. Okay, the total number of vertices are k plus 1. Okay, now what we do is we'll separate this both of the trees. Okay, the total number of edges will decrease by 1 in each of this tree. Okay, means this tree had, if it had m edges, because of this edge removal we'll have the number of edges as m minus 1 here, and here also m minus 1. Okay, so minus 2 will be the number of edges in if you consider both of these trees together. Okay, so k plus 1 minus 2 will be the number of edges. Okay, that means k minus 1 edges. Now considering the whole tree which we had initially, we had just removed one edge. So from t, if there are t number of edges, we had removed one edge. Okay, so t minus e will be the total number of edges. Now since t minus e are the total number of edges, and by considering the individual trees t1 and t2, we got the total number of edges as k minus 1. So one edge will get cancelled from here, and t will have the total number of edges as k. Okay, so therefore tree with k plus 1 vertices will have k edges. Okay, that's the proof. In this question we have been asked to find out the value of v, which is the number of vertices in the following cases. Okay, G is a cubic graph with 9 edges. Now the degree of each vertex will be 3. So by handshaking property, 3n will be the sum of all the degrees, that will be equal to 2 times the number of edges. Okay, 2 into 9, so n will get as 6. In the second case, G is a regular graph with 15 edges. See, if it's a regular graph of k, it's kn is equal to 2 into 15. 2 into number of edges is equal to kn. N is the number of vertices. Okay, and k is the degree of each vertex. Now k can be in that case k will be 30 by n. Now n should be the integer which will divide 30. Okay, so there are many possibilities, like n will be 1, 2, 3, 5, etc. Okay, so those are the possibilities of n. Okay, in the next question we have been given that there are total number of 8, there are total 10 edges and 2 vertices of degree 4 and all other vertices of degree 3. So if there are n vertices in total, that means 2 vertices have degree 4 and n minus 2 vertices will have degree 3. Okay, that's equal to 2 times the number of edges. Okay, on simplification we will get the final answer here as n is equal to 6. Okay, in this question we have been asked to prove that the total number of the sum of all the degrees of the vertices is an even number, and it's equal to the twice the number of edges in the graph. Okay, so consider a diagram here. Okay, so while you calculate the degree of each of these vertex, what you will do, you will count the degree of this edge twice. Why? Because for each of these vertex you will count the out degree, right? So 2 times you will count for each edge. So in that way what we can conclude is that while calculating the sum of each of the vertex, you will calculate the number of edges 2 times, okay, because for an edge there will be 2 ends, right? For each of this degree you will count the edge 2 times, okay. So the sum of the degrees of all the vertices will be 2 times the number of edges, okay. Suppose that there is a graph, and in that graph there are k vertices having an odd degree, and the remaining vertices, which is n minus k, have even degree, okay. So what we have to prove is, in every graph the number of vertices having odd degree is even, okay. So see here, the sum of all these degrees will be written here, that will be equal to number of degrees of odd plus number of degrees having even degree, okay. So we'll be writing here, by handshaking property this will be even number because it's 2 times the number of edges, and the number of degrees having even degrees will also be even. So see here, the final answer is even, okay, and this is a number here x and plus even. So anything when you add it with x here, you are getting as even, so that means x must be even. If it's odd, you will get the answer as odd, but it's even here, so x should be even. That means sum of all the degrees of odd vertices should be even, okay. So after getting that, we can write here as, this is the sum of all the degrees of odd vertices which is even, okay. In each of these means each of these degree is odd, okay. So each of this term is odd, so the number of terms must be even to get the final answer as even, okay. Because if you add 2 times the odd number, you will get as even, but if you add 3 times the odd number, you will get as odd number. So the number of terms must be even to get the final answer as even, okay. The number of terms in LHS must be even, therefore k is even, okay. In this question we have been asked to find out the optimal prefix code, and I have explained the similar question in my theory video. You can refer to that for more detailed information, okay. So first we'll be arranging this in increasing order, then we'll be considering the least 2 terms, which is 1 and 1 together, and take it as a single term, okay. Similarly we'll do for all other terms as well, and we'll consider the summations, okay. We'll be taking these degrees together. Now the least 2 terms will be considered first and taken together. In that way we will form until all the letters have been considered, okay. So after forming all of these letters, what we'll do is we'll write these values here, which is left values will be filled with zeros and right values will be filled with 1, okay. Wherever right subtree will be there you will fill as 1, and the left subtree will be filled as 0, okay. After writing all of that, you will generate the code for each of these letters, okay. See here, the letters are G, R, A, I, S, D and space, okay. For generating the for getting the prefix code, what you will consider is, to reach this point from the root, which all branches you have to pass. Means to reach this leaf here, to reach this point here, you will pass through this branch and this branch, which means 0 and 0. So you will write the code as 0 0, okay. Similarly for all of these letters, okay. After getting this code, you will write this according to these letters, what are the codes you got. In that code way, by using those codes, you will write the answer here. Coming to walks and paths, we have been given this figure, and we have been asked to find out the following. The first one is a walk from B to D, which is not a trail, okay. Not a trail means it should the vertex should not repeat twice, okay. So if it's not a trail means the vertex should repeat twice, okay. The first question is a walk from B to D, which is not a trail. So we'll be starting from V2, we'll go like this, then like this, then we'll be going in this way, and we'll be coming back here, and we'll be coming here, and we'll be reaching V4 here, okay. So from V2 to V4 we traveled, and it's not a trail because V5 is repeated and V2 is repeated, okay. So in this same way we will do for all of these questions here, and I have explained this in the theory part of the video, okay. This same question was there, okay. You can refer to that. Similarly, in this question we have been asked to find out how many ways we can travel from V1 to V8, okay. Means, for example, 1 2 3 4 5. So you reached V8 by passing through 5 edges, so the length is 5, okay. In that way, how many are possible, that you have to find out, okay. So under the topic rooted trees, the type of numerical that can be asked is in this way. A classroom has 10 microcomputers, and each of the wall socket has 2 outlets, and the extension cords that have 2 outlets each, okay, and the total number of cords which are needed for this setup has to be found out, okay. M is the number of outlets, okay, that's the means if this is a tree, okay, how many branches are coming from one single tree, that value is given by M, okay, which is 2, and 10 microcomputers means the leaf nodes in the tree, okay, means the at last how many computers are connected, that is 10, that is given by P, okay. So after knowing M and P, we can find Q, which is the number of cords needed, P minus 1 by M minus 1, okay. So applying that, we will get 9, and the total number of cords needed will be Q minus 1, okay, which is 8. In this question, we have been given that a tree has 4 vertices of degree 2, 1 vertex of degree 3, 2 vertices of degree 4, and 1 vertex of degree 5. We have to find out the number of leaves in the tree, okay. Suppose there are n number of leaf nodes, so the total number of vertices will be n plus 4 plus 2 plus 1, okay. So the total number of vertices are 4 plus 1 plus 2 plus 1, okay. So the total number of vertices will be n plus 7. Now the sum of the degrees of all these vertices is, the n vertices are leaf nodes, so the degree of leaf node is 1, so n into 1, and 4 vertices have the degree 3, so 4 into 3, similarly 2 into 4 plus 1 vertex has degree 5. So the sum will be calculated here, and if the tree has k vertices, that means the total number of edges will be k minus 1. So since there are n plus 7 vertices, the total number of edges will be n plus 7 minus 1, okay. So these are the total number of edges. By hand checking property, we can write the sum of the degrees of the vertices is equal to 2 times the number of edges, okay. So there are 13 leaf nodes present in the tree. For this question, we have to use this formula, n is equal to m plus k. N is number of vertices, m is number of edges, and k is number of trees, okay. So applying this, the values, see here, number of edges is 40 and number of trees is 7, okay. So k and m is given, we have to find out what is n, okay. Applying these values, we get the value of n here. For this question, if the total number of vertices is k, then the number of edges will be k minus 1. So by using this, we can find out what's the value of total number of vertices, okay. That will be total number of edges plus 1, okay. E1 is given, we can get we can find out what is v1. After getting v1, we can find out v2 and e2. v2 is equal to 2 times v1 and e2 is equal to v2 minus 1, okay. For the second question, we can use the formula n is equal to m plus k to find out the number of trees, okay. See here, n and m is given, so by applying those values, we can find out what's the value of k, okay.